Radical equations. That's the hot topic for now. We saw the first type in the previous lesson. A linear equation with a mixture of a radical and non-radical part. And now it is the time for the second one, where they are all radicals, but the expressions inside are still linear. Without wasting a moment, let's start understanding it through an example. So this is what we have. Label it as equation 1 first. Then square both sides of the equation. Remember this formula? Apply it on this side of the equation. Here this is A and this is B. So their squares will get them out of the square root. And here's the 2AB part. Now add the like terms and shift this to the right side. Next up is the multiplication of these two. The square root of x plus 3 and x plus 6. We get x squared, 6x, then 3 times x is 3x, and then we have 18. Now add the like terms on both sides of the equation and name it equation number 2. So we have reduced the given equation to a type 1 radical form. Since we have learned those in the last lesson, so I assume you know how this is going to end, right? Square both sides. 2 squared is 4. The radical sign is cancelled with the square. While on the right, we again apply the perfect square formula. Expand it, and this is what we get. Multiplying 4 by this expression here, so that it is free from the bracket. And then we can shift the variables around. Now we have everything in place. Add the like terms. Finally, a standard form of the quadratic equation is obtained, which can be compared with the general form. By doing so, we see that A is 3, B is 40, and C is 68. Put them in the quadratic formula to get this. You have probably memorized this formula by now. Simplify it a bit more. At last, we can split the two values of x. Simplifying them as well gives us x equal to minus 2 and minus 34 upon 3. Don't rush. Remember, in the previous lesson, we talked about the importance of verifying the roots. That's what we are going to do next. Put x equal to minus 34 upon 3 in equation 1. Now take the LCM of the denominators in each radical to make the denominator the same, as we can't simplify the fractions without it. Solve the numbers. Minus 34 plus 9 is negative 25. Minus 34 plus 18 is negative 16. And minus 34 plus 33 is negative 1. Let's separate the negative sign by writing it as the number times negative 1 in each radical. Recall that the square root of negative 1 is an imaginary number denoted by I. I for iota, right? Hence, the square root of negative 1 is replaced by iota, while the square root of 25 is 5. For 16, it is 4, and for 1, it remains 1. Whatever it is, one thing is for sure, that left hand side is not equal to the right hand side, which means that minus 34 upon 3 is an extraneous root. That makes the other root, x equal to minus 2, an obvious true root. How so? Well, we had a linear equation that has one root as a solution. We had two possible choices. One got cancelled, one remains, and that's our answer. You can even test it out yourself. I'm putting it in the solution set because I know this equation needs one root, and this is the only possibility here. That's it for this lesson. You have covered two types of equations, but there are many more to come, and I have prepared great lessons for every single type. Don't forget to watch them because that would just be very rude of you.